Welcome back, guys. We're continuing on with exponents today, and we are going to be multiplying exponents. So check out this expression at the top here, 3 to the 4th times 3 to the 5th. If I wrote this out, it would look something like this. So 3 to the 4th, that's just 3, the base number, times itself 4 times. So 3 times 3 times 3 times 3. 3 to the 5th, well, that's just 3 times itself 5 times. So that's another way to rewrite this expression. Basically, guys, this is just 9 threes, there's 9 here, multiplied together. So another way to write this would be 3 to the 9th power, since there's 9 threes. Okay, that's pretty much the idea for today, people. Shortcut, we love shortcuts. Because I don't know about you, I don't want to write out 9 threes every time and then count them up, 4 plus 5. I don't want to do that, so there's a major shortcut here, and I bet you can already see it. But if you have something like 3 to the 4th times 3 to the 5th, you can just add the exponents when the bases are the same, and then that would be your new exponent, 3 to the 9th. Okay, so shortcut, just add the two exponents together, and you avoid completely rewriting this whole thing out. Of course, you know, we like to be like super mathy and generalize formulas and write it maybe something like this with all these letters, but they're just saying like a to the m times a to the nth. So point out that like the bases are the same. They're both a's, or they both have to be threes, they both have to be h's or twos. The big part of your exponential like expression has to be the same. Okay, I couldn't do like h to the 5th and g squared and add the exponents. That doesn't work. Okay, the base has to be the same. If it is, you just do m plus n, you add the exponents, and boom, you're done. So a couple things like we said to point out, bases need to be the same, and realize we are multiplying exponents here, so it needs to be multiplication between your two exponential things here. Otherwise, this trick, this shortcut, does not work. Okay, here we go. So again, all this exponent stuff, just like last time, it really just takes practice. It can be tricky because every example is a little bit different, but the more you practice, the better you'll get. So let's just do some of that. The directions stay really plain again. It's just going to say simplify. Okay, so think about what we learned last time. An expression is not simplified if it has 0 and negative exponents within it. So you got to take care of that. There can be no 0 or negative exponents. Okay, if you leave your answer with a negative exponent or a 0 exponent, you're not right, you're going to get points off. Take care of those first, and then remember step 3 from last time. I told you to evaluate any numbers. So if you've got something like 3 squared, you should write 9 instead of 3 squared. Just make it the best answer possible, is basically the goal of simplify. All right, so number 1, I've got my little multiplication shortcut that's going to apply here because the bases are the same. They're both h's. So if I just add the exponents, 5 plus 2, that would be my new exponent, which would obviously just be h to the 7th. There's 5 h's here, there's 2 h's here, so total there's 7 h's. Okay, same thing here. The bases are the same, they're both 2's. You're just counting how many 2's there are here. You should never multiply the 2's and say this is 4 to some power. That's a huge mistake people make, a super common mistake people make. I'm just counting how many 2's there are. So therefore my answer should be like 2 to some power. Okay, go ahead and use your shortcut because the bases are both 2's. So I can just say 7 plus negative 3, that's just positive 4. So that's my new way to rewrite this, 2 to the 4th. And then guys, here's where you would want to evaluate the number. Like you can actually make that better and just write what is 2 to the 4th. Sure, you can use your calculator. Whoop. But it's just 2 times 2 times 2 times 2, which is 16. Okay. Number 3 is kind of like a trick question, kind of. I cannot add these together and say it's something to the 11th power. It doesn't work because the bases are different. This is a B, this is a C. The parentheses mean nothing, they just mean multiplying. But I couldn't do anything here, so I actually just have to leave it. Can't put anything together. That is simplified. All right, number 4. So all of these bases are m's, so that means I can just add my exponents together. So -9 plus 5 is -4 plus -2, that's -6. If that is a struggle for you, just add it straight up in your calculator, all your exponents. So this can be written as m to the -6th, but this is not the answer because this isn't simplified because I have a negative exponent. Okay, so go back to what we learned last time. To make an exponent positive, you just move it across the fraction line. So the best answer here, m to the +6, needs to be on bottom over 1. A lot of times people do make it positive, but they forget to show me that it's on bottom by doing like 1 over that. So don't skip over that step of showing me that this is on the bottom. All right, number 5, bases are the same, so I can add my 2 exponents, and 8 plus -8 is 0. So, and don't do 6 times 6 is 36. I'm counting how many 6's there are, so it's 6 to some power. 6 to the 0, guys, is just 1. So that's my answer. Number 6, another trick question, kind of. We're multiplying exponents here, not adding. Okay, I actually can't add these two together at all. I can't say this is p to the 11th because it's not multiplication. These are not like terms, so they can't even be combined at all. So addition is totally different than multiplication here. That's already simplified. You leave it alone. Don't be fooled. All right, number 7. Again, we need to do a lot of practice. I know it can be kind of dull and boring, but practice helps you get better here. So if I see something like number 7, the parentheses, again, just mean multiplication. Don't let that throw you off. If you've got like plain numbers and exponent stuff, take it one part at a time. So I'm going to start by actually multiplying the numbers. So big numbers, actually multiply them here. 2 times 3 is 6. I need to put the n's together, and I can do that because they're both n's. So I know my trick is I add the exponents. This is where people start to make mistakes. This is a multiplication problem. So big numbers get multiplied. Only exponents get added. Okay, so 5 plus -2 is how I bring the n's together. And 5 plus -2 is 3. So I would say 6n to the 3rd as my answer. It's the same idea on number 8. I'm going to actually multiply the big numbers. Okay, I'm going to do 6 times 3, which is 18 times 2. That's 36. So actually multiply the big numbers and then add the exponents to bring the y's together. So there's 3 y's here, there's 4 y's here, that's 7. There's 1 there if they don't write the exponent. So there's 8 y's total. So it'd be 36y to the 8th. On number 9, again, don't be like too quick to just add everything together. You can only combine the exponents that have like bases. So that would be the c's here. I can do 4 plus -8 and get c to the -4. The d term is going to kind of stay what it is. And then to simplify this, I know I can't leave that -4 exponent, so I got to move that to the bottom. So the best answer would be d to the 3rd over c to the +4. You guys will find that this stuff individually it's not too terribly difficult. It's when you throw everything together and there's so many rules that it gets complicated. I want you guys to try 10 and 11. Okay, show me what you get on those. I'll check those next time. I'm going to end with number 12 here before we do some scientific notation stuff. Number 12, I'm going to put terms together first. So I see negative exponents right away, and I guess I should have mentioned that back here. Don't move stuff first. Like, don't put c to the 8 on bottom because you see that it's negative. Combine first, then move. Okay, so what I mean by that is, like, I have k terms on top, n terms on bottom. Put them together first to just make one k term and one n term, then see if things need to be moved. So on the top here, that's k to the 1 times k to the negative 3. So I can add those together. 1 plus negative 3 is negative 2. On the bottom, those are both n terms, so I can add those exponents. Negative 7 plus 4 is negative 3. Now I can see, all right, they're both still negative, so the k term needs to come to the bottom and the n term needs to come to the top, so you're basically just flip-flopping this thing, and it'd be n to the positive 3 on top, k squared on bottom. All right, I told you the first lesson, we kind of relate all this stuff as we go along back to scientific notation, so here is us doing that. They're going to ask you to multiply two scientific notation numbers here. Okay, we're multiplying exponents, and scientific notation uses that, so it works. I would look at this and say these are two really big numbers because I see two positive exponents. So to multiply two really, really big numbers and write my final answer in scientific notation, what I'm going to do first is multiply the a values. Remember scientific notation, like the general form looked like this. So the a value, that's just the first number. So that's those, the 2.5 and the 6. All right, I'm going to do that first. So that's 15. Then you bring the tens together. Okay, so to do that, the bases are both 10. Therefore, I can use my little shortcut for today, and I can add the exponents together. So that would be 8 plus 3, that would be 10 to the 11th. So the shortcut, not using your calculator, is you can put these together and make one scientific notation number, multiply the numbers, add the exponents for the tens. You have to make sure, so step 3, don't skip over that, you have to make sure your final answer is actually in scientific notation. Like, check it out, this is not in scientific notation because 15 is not a number between 1 and 10. And remember that it needs to be. So I need to move the decimal to make it 1.5. Remember, if you move the decimal, you have to change the exponent. So our trick was, if we make the number smaller, which I did, it was 15, now it's 1.5. I made the number smaller, so I'm going to make the exponent 1 bigger. Only moved the decimal once, so I only add 1. So that would be my final answer, 1.5 times 10 to the 12th. All right, let's do one more. We'll practice this a lot tomorrow. Multiply the a values, so that would be 9 times 7, which is 63. Add your tens, negative 6 plus 2 is negative 4. I need to move the decimal because this is not in scientific notation. And again, I'm making the number smaller. I went from 63 to 6.3. So I need to make the exponent 1 bigger. Don't let negatives fool you. All right, that's multiplying exponents.